So GCMS batch file has completed. So we should have those files available. We're going to open up post-run analysis. And we are going to look at the two most recent files. So let's get into the 2021 labs. Do this by when they were acquired. So 65A-1 and 65B-1. 65A-1 is the crude. 65B-1 is the recrystallized. So we'll open up 65A-1. Notice we got a couple of peaks here. So we're going to do a integration. Take the defaults and see if it works. Maybe not, because we want it to integrate that peak. We don't really want these little tiny ones. So I'm going to go into the program here. It's turning off the integrator at 9, but I don't want to do that. I'm going to delete that. So that's making it pick up that peak. But then these peaks are really small. I don't want those. So I'm going to go to the qualitative table, and I'm going to look at my total ion count for some of those tiny peaks. And it looks like those areas are somewhere in the 800,000. If I set my minimum area to 1,000,000, I can make those peaks go away. So I'm seeing just the two actual significant peaks. There's that one, which has a couple of peaks at 213 and 215. And then there's that one here, which has some much higher molecular weight peaks, 286. Doesn't look like there's any bromine in that one, though. This one clearly has bromine in it. Possible that's a carryover from the person who was running this before me. So I'm going to save that file, and then I'm going to open up the 65B. And you'll notice this one only has that one peak, so I'm going to integrate it. Again, it's picking up a little tiny peak here, which we probably don't want. Right? And if I look at the qualitative table, that's only 0.32% of the area. It's not clear what it is. 207 isn't the molecular weight that rings the bell here. So that only has an area of about 111,000. If I set this minimum area to 200,000, that'll make that peak go away, so that I'm just seeing the one significant peak. There is a peak here, and it looks like a molecular weight of about 273, but it's tiny. I'm going to go ahead and, in the peak integration, I'm going to not turn the integrator off at 9. See if I can get it to pick that peak up. Yeah, and it is picking up a couple of extra peaks here. One there and one there, 253. This one almost looks, if you look at this guy, it looks like it's got a 253 and 254, so that's not an M&M plus 2 peak. So it's not clear what those things might be, but they're small. Right? Total area percent of only like 3.6%. It's 96% is the one compound. And there is no acetanilide, which showed up at around 7. So that's good. That's promising. So 65A has this weird peak out here at 286. With no bromine. That's kind of a mystery. It's not one of the impurities we would expect to see in this reaction necessarily. So, maybe something that was sitting on the column. I threw the sample away, so I can't run it again right now, but well, not too worried about it. It is significant, though. It's 30%, 31% of the total material. Well, we'll run a literature search and we'll see what that looks like. So let's go to the similarity search. See if it picks something up. It thinks it's trioctyl phosphine, but that's only a 63% similarity, so that's pretty poor. There's nothing in the library that it's matching up with well. This peak here, oops, if we run a similarity search, it thinks it's N,4-bromophenyl acetamide, which is 96% match. That's a good sign, right? Because that's actually what we think we made. The acetanilide, right, when we did a similarity search on that, that showed up as a 96% match to N-phenyl acetamide, which is acetanilide. So we're pretty sure that's acetanilide, and it was quite clean. And then 65B just really has that only that one peak. We can go on here and see if it looks like anything matches. 68% for the best match, that's terrible. And this one out here, 59% for the best match. So these peaks are not going to be detecting anything. There's no real point integrating them under those circumstances. So we'll put that integrator off back in at number 9 so we don't have to see those peaks, and save that data file. So we want to print these. I'm going to go to the top menu to the report format file. And I'm going to open the report format file called Bromination Report. And I will drag 65A in there. And we will print it. That's pointing at something from the Ohio Soybean Council. That was the previous sample, which is what I think might be carrying over into ours. And then we will drag 65B into the same report form and print it. So we have those two printouts. So it looks like we did a pretty good job on our purification, and the bromination reaction seems to have worked this time. So both of those are good things.